Welcome. My name is Ryan Hallback, and I am a Principal Intelligence Analyst at the Vertex project. So here, what you have here is our Synapse user interface for those of you who've never seen it. And right now I'm in my research tool. And I'm going to go ahead and just get started by explaining the use case. First, what I'll do is pivot over to an internal Jira instance that we have here to show you what this use case is centered around and what this intelligence request actually looks like. In this particular scenario, what we have is a threat intelligence request that comes in from our internal IR team. They are on the ground working at a customer site where they're doing a compromise assessment, and they found a set of 3 suspicious files, and they need our help. They have a lot going on. What they want our help with specifically is, hey, can you tell me anything about these files, right? Are they malicious or benign? Can you tell me if they are associated with a known malware family or threat group? And also, do you have any detections that we can use for this threat activity if it is malicious that could potentially help them with hunting in the customer environment and even potentially remediating the threat in the environment as well? So this is what the ticket looks like. We see the customer here. We have FOMO Aviation Technologies, the location, and we also have the analyst that put in the request. Now, going back to Synapse, what you can see here in my research tool, one of the first things that I want to do and that I like to do whenever I start performing analysis is creating a fork view. In this case, I'm working from a fork view. I've switched from a live view where I have active production data to a fork view that I've created right before I started this webinar. And I do this because a fork view essentially gives me an analytical scratch space that I can work on top of and where I can have a view of existing data that's underneath. What this allows me to do is ingest data, annotate data, and do analysis freely and feel free to make mistakes. And once I'm done with my analysis, if I'm happy with my analysis, I can choose to then merge all of that data into the underlying data that I've forked on top of, or I can choose to discard that data in part or in whole. So right now I'm in a fork view. We're working within a safe space. Now what I want to do is come to my query bar. I'm currently in lookup mode, but I want to switch to storm mode, where this allows me to actually enter a storm query. And the storm query that I'm going to execute, where storm is our native, analysis and query language that allows us to interact with data in the system. So that's create data, tag data. I just entered a storm query that pulled up a project ticket node in our system. This ticket node actually represents the ticket that I just showed you in our internal Jira instance. The reason this is important for me as an analyst is because I no longer have to go outside of my analysis platform to see what workflows or see what tasking I have. I can actually stay within my system to take a look at my tasking and take a look at the indicators that may be associated with that ticket. The way that this ticket got ingested into the system was using 2 things. It was using automation. Here specifically with automation, I have a cron job set up that calls and reaches out to our internal Jira instance every so often, every hour, polling it for new Jira requests that come in that have a high ticket value. This allows me to stay on top of internal requests that come in. And that cron job is then calling a Jira power-up that allows us to model Jira tickets directly in our system, and not just model the Jira tickets as you saw them, like the name of the Jira ticket, the description, and other important properties, like even where it's located internally, but also pivoting from this ticket itself. I can see that I was able to use that power-up in addition to our script tool to extract those critical indicators from the ticket and track them directly in the system. So not only do I have the ticket, but I also have the indicators that I need to investigate. So let's go ahead and get started. So what I'll do now is query these indicators to just get them into my view. And these are the 3 files that I need to investigate. In Synapse, we use this at Vertex, we use Synapse as well as our customers and adopters. You're going to use Synapse as your system of record. So that means that anything that we previously know about an indicator or a node is going to be captured here forever unless it's deleted. When you click on node, there are several ways that you can try to ascertain what context you have about a file or any indicator, if it's an IP, if it's a domain. When I click on this node here, I'm in tabular view. I can look at the properties that are extracted for this file. So I have the compile time, the size. The node properties can be displayed here in the column. They can also be here on the side in the node detail pane. Here are all of the properties that we have populated for these files, and it's not much. If I click on all props, I can see all of the potential properties that can be populated for a file. So everything from the import hash value to the MI and PE size to the name of the file itself. Right now, what we see is we don't have a lot of properties populated because that means we don't know much about them. Coming down, that's the case for all of these files. In addition to the properties that help give us context, that key metadata about that node, we also use tags. Tags represent analytical assessments in Synapse. So tags help us contextualize a node. They also help us cluster nodes in the graph to show how nodes are related and show that a relationship does exist when one isn't inherently available. The only tags that these nodes have is the tag that was introduced to the system by the Jira PowerUp. So this is a tag indicating that this is a part of the current case that's being worked on by our IR team. So we don't really have a lot of context here just by looking at these files in this way. And then when you pivot over, what you see is I can also use the connections in the graph to get an idea of what we know about these files. And so when I did my exploring and pivoting to directly connected nodes, once again, there's not much there. So that means that I need to go out and get more context. In Synapse, the way that we get more context, the way that we enrich data is by using power-ups. I'll go to my power-up tool to show you what these look like. This is currently a list of all of the installed power-ups that we have in the system. And power-ups are just effectively services that extend the base functionality of Synapse. So anything that's not shipped, within the base, deployment of Synapse, you can create a power-up to extend that. So if you have an API that you want to go out to, like a third party, to enrich a node and pull in more data, like Alien Vault, for an example, we create power-ups for that. We have power-ups for Integer, power-ups for MITRE, so on and so forth. So we have several power-ups that we can call on to pull in more data about these files. The way that you can execute power-ups, you can execute them by the command line. You can leverage automation, so maybe a trigger or a cron job. Here, what I want to do is leverage a node action, which is really just a shortcut that could be created by an analyst, or sometimes we have power-ups that go ahead and create node actions as well, just to make it easy for the analyst to invoke them as a part of their workflow. Here, I'm going to call a node action that's calling a macro that I've named enrich. And while that's running, I'll go over to that macro to show you what it looks like. Going to my Storm Editor tool, and I'll pivot to my macros tool. These are all of the macros that we have stored in our system. And a macro is essentially just a set of stored Storm code that anyone can use in the system and invoke. When you take a look at these nodes, when you take a look at the macro, which you can see what it's doing. Here, what it's doing is switching based upon the form that it's encountering. So for an example, if it encountered a file bytes node, what it's going to do is come down here and call the census power-up, the VX Intel power-up, and the virus total, so on and so forth. It's going to call all of these power-ups in tandem and perform bulk enrichment for me so that I don't have to call them one by one, which makes my workflow a lot easier. So what I see here is it's still running and it's running live, and it's pulling in nodes from the APIs that I've asked it to go out to. The important thing to note about this is sometimes when you're pulling in data, you want to be cognizant of maybe your capacity that you have for certain APIs. You also want to make sure that, hey, you're only calling enrichments that, that matter at a particular time. So here, what I'm doing is calling about maybe 10 to 12 APIs or enrichments so that I can pull in more data. So I'm just going to go ahead and wait for this to finish running. So far, it's performed over 1,000 edits on about 200 nodes. Here we go, it's coming. So normally, the way we do our enrichments, when we're doing, supporting IRs, or especially when we're doing OSINT and codification, what we do is we leverage automation. So we have, a set of triggers in place that will go out and enrich, nodes that are associated maybe with a particular story, or maybe even IOCs that get a particular tag. In this case, and we see that our enrichment just finished. In this case, the only reason that I ran it manually was because I'm doing a webinar, and I wanted to show you exactly what that looked like and show you what it looked like when the data got in the system. So here, if I go ahead and refresh my query, I can see that my view has now changed. One of the first things you may notice is that the color of some of the nodes have changed. And this is because we have tag coloring rules that are in place. If I go to my workspace tool, what I see is that under preferences, I have tag colors that I can specify as an analyst to customize my analytical environment. So what that means is that anytime I have a node that's tagged with a particular tag, I can specify how I want that node to appear to me. So for an example, if I have a node that's tagged with CNO common, maybe I want that to show up in blue. Or if I have a node that's tagged with CNO mal to indicate that it's malicious or a part of a malware family, I can have that show up in pink. So it's kind of analyst choice here. So looking at these nodes, this is great. I can see that, hey, I have more context, and that context is apparent. One, because I have more data populated in the columns and over here in our, with our properties. And I also have more context in the form of tags as well. Also, if I select all of these files and pivot over, if you recall, when I did my initial pivot, I only had about 5 or 6 or so nodes that were directly connected to these guys in the graph. Now, what I have is over 1,000 nodes that are directly connected to these files, which means that I have more context and potentially more insight that I can gain and glean that would be useful for the IR team. So I'll go ahead and get started with this first file, that's white. I'm taking a look at this. What I can see is I'm working with a Windows executable. I didn't know that, beforehand. I see the compile time, the size. So this is some good initial context. If I come down, one of the things that sticks out to me is, in addition to the color, I know what color, the white means to me as an analyst, but you can see that I have more context in the form of tags. What we've done is we've gone out to several APIs. In this case, we have hybrid analysis, and we've pulled in context from hybrid analysis. So hybrid analysis has assessed that this file is, whitelisted. This is a known file, so they deem it to be benign. If I look at VirusTotal's assessment, which is indicated by RepVT, they also indicate that it was distributed by a known distributor and that it's also trusted. So this is some initial context that I can use as I go ahead and investigate why do they think that this file is benign, or it's a known file. Here, if I use my scroll to form tool, I can see all of the forms that are directly connected to this particular node. And maybe I want to take a look at the file path to see some of the PBD information to see if that gives me more insight. What I would typically do is look for antivirus hit information or forms to indicate that this particular file hit on an AV signature when it was executed in a sandbox environment, but I don't see that. So one of the things that I would go to is the VS version information node. What this form represents is a file version resource that was extracted from a file. And it's indicating to us, the original file name, the product version, also the organization that created the file, and the description. So what I can see here is that this is actually the registry initializer file that's common to Microsoft. And it was created by Microsoft as well. I've seen this before in supporting IR engagements. So as analysts, we all get familiar with tools that may be benign, but used in a malicious capacity. And that appears that this is one of those files. Sometimes they use what's actually on the system, or attackers bring their own tools. But what I see here is that this is actually a legitimate Microsoft file. So I've been able to just kind of pivot, use some external context from third parties and just make my initial assessment of, hey, great, this first file is not malicious, it's benign. Then what I want to do, I'm going to go ahead and skip down to this pink file, because this pink file is kind of staring at me in the face based on my tag coloring rules. What I can see here is, once again, I have more properties that have been appended to this file and extracted out by our file parser power-up. Specifically, I have a compile time and import hash, that's valuable to me for pivoting. And then also have some context down here and tags that's really useful that I want to talk to in a little bit. But first, let me focus on the properties. When I'm doing malware analysis and clustering, one of the things that I love about Synapse is the fact that it extracts all of the key metadata that's associated with a node, and it appends it. It creates properties and populates those properties with relevant values for that node. And all of those properties then become pivotable, and they allow me to potentially identify key clusters of relevant data. So in this case, for an example, for this file, what was identified within this binary was the compile time. So when it was compiled by the developer. It also identified the import hash, the size, the name, and it put it on the file. The reason this is relevant is because I'm able to then come here, for an example, and take this compile time and query this compile time to identify all of the other files in my system that have this same exact compile time. This is a storm query here that was generated automatically by Synapse, and I just said, hey, execute this query for me. What I see is I have other files that have the same compile time, and if I look at their context, I have context from hybrid analysis and VirusTotal here. If I keep going down, what I see is one of the files in pink, once again, it has an actual nanocore tag, which is pretty insightful. This one doesn't have much context here. And this is the file that we're actually investigating, which once again has the nanocore tag that we'll talk about in a little bit. Going back to my original query, I can still use additional properties if I wanted to when I'm doing clustering. For an example, the import hash value, to see if I get more files that come up. In this case, I get more files that share the same import hash value than I did with the PE compile time. Maybe this is a good import hash for me to pivot off of, maybe not. But what I can do is start to, click on these files to look for trends in the data. I'm looking for size, looking for similarities in compile time. And I'm also looking at the tags for context. Once again, another nanocore sample pops up. Here I have this file that's been identified as malicious, and this one is associated with the threat group that we internally refer to as paper trail. And I can see that this particular file has been reported previously by Clear Sky. So as I go down, I'm getting more and more information about files that have overlapping properties with the file that I'm investigating. Once again, I have nanocore coming up again, but this time, this one is attributed to APT33 by FireEye, which is something that I can keep in the back of my mind. If I use the up arrow to go back to my original 3 files, and I click on this one that we're investigating, in addition to looking at some of the properties for key overlaps, what I want to do is take a look at the tags. So if you recall, tags are used in Synapse to help us contextualize nodes. In this case, I did not manually apply this tag. You saw me click on this node before we started with the enrichment, and it didn't have a tag, nor did you see me manually apply a tag. The way that this tag got applied is through the use of automation. And specifically, what we have in place is a set of automation, a trigger that will go ahead and it will propagate tags, CNO tags that, exist on a node. Here it is right here, propagate YAR rule tags. So CNO mal tags that exist on a YAR rule to any file that matches that rule. So in this case, this is what has happened. We've applied this tag to this file because it matched on a YAR rule. And that happened when we ran our enrichment macro. And then we also have this tag here that was applied to let me as an analyst know that, hey, someone needs to review this to make sure that this tag is correct. So that's what we're going to do. Let's take a look and see if this is lining up to actually be a nanocore sample. So when I explore from this file, once again, we can see how many nodes are connected to this file now in the graph as a result of enrichment. One of the first things that I want to do is go down to see if I have some AV file hit information, and I do. So like I mentioned before, this file hit represents, an actual antivirus signature that matched on this file when it was detonated in a sandbox environment. So in this case, this is good because we're seeing a lot of specific signature names when we look at the signature hits that we have. Sometimes you can have generic names, like generic or backdoor, or you can have more specific names like nanocore to indicate what antivirus vendors are deeming this file to be. So in this case, we have a lot of, AV vendors, obviously not just saying that this file is in fact malicious, but that it may be an actual nanocore sample, which is good. In addition to, this file hit information, the next thing I want to do is pivot over to the YAR rule, that YAR match that actually caused the tag to get applied to this file. In Synapse, whenever we execute our YAR grid power up against the file, that is a way of us taking a YAR rule that we have in a system and seeing if it matches against any files that we have in the system. And if it does match, we store these nodes in the system forever for people to see that, hey, this does match on this particular YAR rule. So if you look here, we have 2 YAR matches that occurred for our file. We have a nanocore generic 2, and then we have another nanocore February 18 rule name as well. If I select these matches and pivot over, I can see and take a look at the 2 YAR rules themselves. I can hover over the text to see what's contained in the rule, or I can double click to take an in-depth look at the rule itself. And maybe I want to do this because I want to know who wrote it. Is it something that was written by a teammate or a third party, like this one was written here? Is it kind of broad and just loose and looking for everything, or is it written pretty tightly? So looking at this one, what I can tell is not only from looking at the content, but also by the fact that it has a tag applied. This means that another analyst already evaluated this rule and determined that it's good to go, such that anything that matches this rule, it deserves to get, a nanocore tag applied. And this is just helpful because I can keep pivoting to not only see that obviously our samples have fit on this rule, but I can identify other samples, nanocore samples in our system that have matched against this rule as well. And this just may be helpful from a clustering standpoint or just a context standpoint, for data that I can pass to our IR team as they're conducting their investigation. If I use my breadcrumb feature now to go back to, my initial pivot from the file that we're currently investigating, one of the last things that I want to take a look at is the set of DNS requests that are associated with this file. When I'm looking for, not looking for malware clustering, I don't want to just take a look at, some of the static information or host-based activity, but I also want to take a look at some of the, the network activity that a particular binary causes. So I can do that using INET flow data. And I can also do that using the DNS request data that may be generated by the binary. In Synapse, DNS request nodes, what they represent are DNS resolver requests that are made by binaries or by, an entity when it's, executed. So in this case, we have our file that has made a DNS request out to this Cactus 04 domain. This is important to me as an analyst because these DNS requests, they can be one of several things. They can be, standard, DNS requests that are made for a certificate. So maybe a no Microsoft domain. It could be a network connectivity check for a benign domain, or it can be indicative of a C2 node. If I pivot over, what I can see is by clicking on this file, I'm sorry, not this file, but this FQDN, that this FQDN was not previously known to us. And I know this, for several reasons. One, I know it because I don't have any additional context here, no tags, nothing insightful. But more importantly, if I look at the .created property, I can see that it was just created today as I did my enrichment to pull in some sandbox execution data. So we didn't previously know anything about this file. We don't have any additional context. But what I can say, in looking at the execution of it, the fact that it's a dynamic DNS domain, and it's not a domain that's common, is that this is shaping up to be a nanocore C2 domain, and that's likely. So what I would want to do is pass this indicator over to our IR team to say, hey, maybe this is something that you want to check your logs for to see if you have evidence that this binary was actually executed in your environment. So going back, I have some good information about this file. It looks like nanocore. I even have a C2 node. So lastly, what I want to do is take a look at this file. This file is different because it's not a Windows executable. Instead, this is a Microsoft Word document. Hybrid analysis says it's malicious. And VT also gives me some context by saying, hey, it has some macros and it's obfuscated. If I pivot over from this file, there are several things that I can look at as well. Once again, going to my AV hit information, I can see that this file is flagged by a lot of AV vendors as being malicious. I don't have a specific name here, like I did with the nanocore sample. I'm getting a lot of generic names, but at least I know that this is in fact malicious. Something else that can be a good indication of maliciousness is, like I mentioned before, the INET flows. I didn't pivot through the INET flows with the previous sample, so let me do that here. When I look at the INET flows, this is telling me, what network activity, what IP address, what endpoints this binary connected to. So in this case, we have this 95 IP address that this binary was observed connecting to when it was executed in the sandbox. When I click on this IP, just based on the tag coloring rules, what I can see is we have some context about this file. About this IP address. It was previously seen, we have these dates. It was created in early of 2022, so not just seen today. But looking at the tags, what it says is that we've previously identified this IP address as being associated with sinkhole infrastructure, which means that the C2 that this binary calls out to has been sinkhole. So that's insightful, just from the standpoint of, hey, the C2 domains that are contained within this binary, they are in fact malicious and previously known. If I go to the DNS request for this binary, what I can see is the actual C2 domains that this file is calling out to. It's calling out to two zones, actually. We have this Windows kernel 14 domain, and we also have this MS Word update 17 domain. So if I select these first two rows here and pivot over, what I can see is, looking at context, is that this Windows kernel 14 domain was already attributed to a threat group that we internally refer to as Paper Trail. We've assigned some context to say that, hey, this is masquerading as a legitimate Microsoft Windows domain. And this was also previously reported by Clear Sky and linked to the Copy Kittens threat group and Operation What's Up Tulip. If I pivot over one more time, what I can also see is not only did we previously know about the Windows kernel 14 domain, but we also knew about the MS Word update 17 zone. And in the same vein, this is also attributed to the Paper Trail threat group. We have some masquerading context. And then once again, this was also previously reported by Clear Sky. This is encouraging because it's letting me know that while I may not know exactly what this Word document is, I know it's malicious, and I know it's been being used by a threat group that we're internally tracking. And if we're tracking it, that means it must be important enough for me to pass it on to our IR team for additional context, which would be important. Now that I kind of have some malicious context, and I know that this file is associated with the Paper Trail threat group. One of the things that I, may want to do is, keep pivoting to see, just how far these connections go down. I can take a look at some of the media news nodes that are associated with the Copy Kittens threat group, since that was reported by Clear Sky, and maybe even pass these indicators off to our IR team, such that, if they want to use them to scan in their environment, they can. But one of the things that I want to do personally as an analyst is take a look at this Paper Trail threat group as a whole, just because before I make my final assessment that this is in fact the Paper Trail threat group, I want to make sure that what we're seeing here with this sample is in line with their usual TTPs. Here I can look at everything that we've attributed to this threat group by pivoting from the organization node that we've used to represent this threat group. Because at Vertex, the way that we represent and model threat groups is by creating organizations for them. Here, what we have linked to the organization is everything from, crypto search that we've seen them use, files that we've seen them use, even DNS requests that their files have made. So what we're starting to see is, yes, we've seen the MS Word Update 17 domain before. Once again, we have more domains, masquerading as legitimate Microsoft domains. So this is, definitely lining up. Something else that's lining up as well would be the industry targeting. What we do internally is track, the industries that we've seen them target. And if you recall, when I first started, with this use case, our customer, FOMO Aviation, was a part of the transportation industry. So even the targeting is lining up as well. And then lastly, what I want to point out is one of the things that our IR team asked us for were detections that could potentially help them identify more activity associated with these indicators in the customer environment. Well, what I could pass them and something that's associated with this threat group's profile are these 2 YARA rules that we have here that are linked to this threat group and has previously been used to help us detect them in the customer's environment. So this is great. So now that I have, information about, this threat group, and I know what these indicators appear to be, one of the last things that I want to do is apply some context for these files and kind of close out and wrap up my investigation. So for this first file, one of the things that I would do is come in and add the context of CNO common to indicate that, this file is commonly encountered, and while it may be, relevant, depending upon the situation, it's not inherently malicious. For this file right here, if you recall, this is the Word document that we just linked to Papertrail. So I would say that this is malicious. I would also apply a tag of CNO threat Papertrail to indicate that this is attributed to the Papertrail threat group. And then lastly, I don't have to come to this last file and manually apply a tag. All I need to do is drop down and remove the internal review tag because I have actually reviewed the tag and I agree with the assessment that this is an core sample. So now when our IR guys come into the system, they will now see the context that's associated with this file. The way that I would tell them, that they can now come to the system to get this, additional context, I would come in and close out this Jira ticket by resolving this issue directly from within Synapse. They would get whatever alert they have set up and say, hey, Ryan is now done with her investigation. And the reason that's important is because when they come into Synapse, now they see the context that's directly on these nodes that they can leverage and communicate with their customer. They see that, for an example, this file has a tag of Papertrail. So they can themselves come in and execute this Papertrail query to see all of the indicators that's associated with this particular threat group. And then lastly, if they needed to provide, some type of writing or something to the customer to help them understand exactly who's targeting them, they can come to our stories tool to potentially get a report on the Papertrail threat group that we previously created. And then lastly, they can export the story related to Papertrail or this particular threat group report to a PDF form, and then email it out to a customer if this is something that they need.